Okay, this is the history of computers. I had a pretty long career in IT, like 60 years, and this is what I kind of saw in my work. I saw the advancements and also a few facts I picked up. So, what is a computer? Well, a computer consists of two main elements. It has to be able to calculate, and it has to have a programmable function so that you can repeat the calculations or you can put in steps on what it's calculating and when. So early in 1822, British government gave some money to this guy named Charles Babbage to create what I call the first computer way back then. And it came out, it was basically a mechanical monster, huge, but it fit the criteria. It calculated and it was programmable. So in America, we didn't really get into commercial computers or useful computers until about 1945 or 1946, when we generated these big mainframes, and we call that the first generation of computers. They were basically our fast memory, although it wasn't fast, was based on vacuum tubes. And our secondary memory, like we have on disk right now, was latching relays. And it was really slow because it was like latch time of 65 milliseconds. Here's a picture of an early computer mainframe. And actually, if you look at this is pretty bulky, big. This big thing here is a punch card reader. And we'll talk about cards after this slide a little bit. Back here, you see big bays, and this contained the basic memory of the computer. In the case, it would be a lot of vacuum tubes, for our fast memory, and it would be a lot of latching relays. And then we had some other computer equipment there. Now, what's not, and a little printer right here. What's not apparent is under this flooring, there are ducts of air conditioning, and the air conditioning would come up and keep the vacuum tubes cool. And that was very important because a lot of heat generated in the vacuum tubes. I was on a tour of a Sage Direction Center one time, and they were using over 50,000 vacuum tubes in that center. And the statistic was given that if they cut the air conditioning off and they left the power on the vacuum tubes, everybody in that building would fry within 7 minutes. Here's another early computer, and this big thing here is a big control panel with switches and sometimes LED readouts, but I can't really see the readouts so well in this picture. But in any case, the way we communicated with a computer was via control panels, and still do. But we have other devices that are better and more sophisticated now, of course. And what got me about this picture is if you look at all these guys' eyes, you can see the admiration in them. They're looking at this dude right here. He must be the computer genius of the data center here, because they're just saying, wow, look at this guy. Here's some ladies that are holding up some of the vacuum tubes used in a computer, and you can see how massive these things are, so you can just appreciate the kind of heat they did generate. Another early one, this one's a little specialized because they had this tube. We didn't have CRTs then to communicate with the computer, so this was some other special oscilloscope or some type of scientific device. But the other things, here's your card reader, card punch. You can see this stack of cards. Okay, data cards are in this hopper here. they're ready to be read in to the computer from this card reader. In the background, you see a lot of big mag tapes. And if we had a lot of data we had to save, and we weren't sure that the computer memory would save it, we would put that on mag tapes. Okay. Here we have a typewriter hooked up to the computer to communicate, and some paper tape devices right here. And again, this was a big mainframe. Okay, here's a punch card, what they call an 80-column punch card that they developed for early use in the mainframes. And you can see a lot of data there. And the way they generated these cards was what they call this machine here, key punch machine. They had the old 26 and later the old 29. And the blank cards would be come down on this hopper, be fed right here, and then the operator would punch this little keyboard right here and put the different values in the different columns as directed, and then that card would go up here and be collected as output. My wife, she took training and was a key punch operator in the old days. Okay, early mainframe computers. We mainly use these things for business applications and things that had usually they had like lists, like contact lists, like personnel, name, address, so forth, and for insurance type programs, and for payroll and things of that employee management type of task. Also, these mainframes they calculated with extreme accuracy, and even though in those days, because they were fairly slow, they used them for special calculation, big series. They wanted to try to find out the enthalpy of isentropic expansion or some crazy thing, okay? And it would still take hours and sometimes to run through on a computer, but the results were still accurate and better and faster than a human could have produced manually. And of course, computers are also used to generate programs to run on the computers. And that was from day one. They operated in what we call a timeshare or a batch processing mode. Timeshare being you operate a little bit of time on one task, and then you give it to a second task and go a little time, and then back to another task and so forth. Batch being you take one job, you run it till it's done, then you take the next job and the next and so forth. And on the engineering side, we also were generating computers and using mainframes for military applications. And like the one I worked in for air defense operation. Here's a timeline that kind of shows basically the development of computers and the different stages, okay? And we started with the mainframes we've been talking about. And I think the next one, I disagree a little bit with their timing here. I think the next one really was workstations, okay? But doesn't matter. They got workstations and they got mini computers, so whatever. You had the mini computers finally came out, and that they started being used for dedicated tasks. And that's what the process control, they were really great for that. And of course for small businesses, because these mainframes cost a ton of money. And IBM, amongst other people, Burroughs and so forth, UNIVAC, they were wise. They wouldn't sell you a computer. You couldn't afford to buy it anyway. They were leased or rented daily or monthly, and the costs were considerable. And then later on in time, of course, we came out with personal computers, and then laptops, and then today, like smartphones. Okay, when we got to the second generation of computers, that was when the mini computers came out, the dedicated ones. And DEC kind of led that with their PDP-8. DEC is Digital Equipment Corporation, and they were in Massachusetts. and then Honeywell and Hewlett Packard and IBM and a whole bunch of little guys coming out with mini computers, and which of course on the software side we started developing programs to control all kinds of different processes. And then junior mainframes came out that allowed you to use the mainframes for online in a time sharing mode simultaneously for different tasks that required input and output during the task. Okay, well, here's a picture of a mini computer. This is a DEC PDP-11. It's a sweet machine. This is a really good machine, fast machine and good. I think when it was introduced, it was probably about $35,000. Here's a Honeywell mini computer. I worked on this one for several projects, and including the California Aqueduct. You'll see I have a picture of that, and you can see we got a control panel on it where we got switches, and we can still use the control panel to do a bootstrap and get the more automated programs that talk to other devices going. Okay, so the control panel was and it's still a needed item on most computers. And here's A.D. Edmondson, which is probably the largest pumping plant in the world. We pumped just short of 2,000 feet, 2 penstocks tubes going up the hill. That were like 10 feet radius each across, driven by like 80,000 horsepower motors. Okay, and of course the pumps. Here's the Honeywell 316 here. Here's an extension, and by that time we had core memory. Okay, and so you could get additional core memory with money. You'd buy this extension. As far as the control, this is the control room here, of course. The way we interfaced with the operator interface with the computer, we didn't have CRTs, and we didn't even have typewriters at that time. Although ASRs teletypes were out on this project, we didn't have those. All we had was for input getting into the computer were these matrix switches here and a lot of LED output displays. And here's a better picture of a Honeywell 316. You can really see it better that way. And here I am in my leisure suit. Sign of the times. Okay, mini computers. Along with mini computers, really this device called a teletype here, or more formally an ASR-33, became the workhorse. I mean, that was really the good device. What it had on it is it had a typewriter keyboard that you could key data into the computer. It had a printer, so just like a typewriter, that you could output data from the computer. And it had what you can't see here, but it had paper tape input and output devices where you could output paper tape from the computer or read paper tape into the computer. And these communication devices was all we needed or all we had at that time. And all these devices operated at a slow speed of 5 cycles per second. Same time mini computers came out, military contractors, companies like Litton, North America, things like that, Hughes, they all started developing special military computers. This one here I worked on, the project was College Eye applications, and it was a predecessor to the, hey, get out of here, predecessor to the AWACS spy plane, if you know what spy planes are about. What's happened here? There, I've got animals running all over here. Okay. We had applications in here of tracking, guidance, display, reports, and navigation. My task was fault isolation. Something went wrong in this box. We had like 7 cards, and I had to develop a program that would keep control and find out where the fault was, light the light on that card so they could change it and bring the computer back online. Well, in doing that, of course, you had to keep control, and what you did is you did things like duplicate memory, so that if a memory was losing memory, you would still have the program in all the different parts of memory, and verify one thing at a time. Oh, the adder works, well, A register works, well, now the B register works, so forth. And in doing that, of course, we were feeding in little tests from the paper tape reader, and that was slow. So it took 20 minutes to go through this thing and light the light on the bad card. And I still thought, as a young programmer, oh, this is great, man. Of course, as I got older, I thought, 20 minutes, I could have changed these cards out 5 times. The big enemy, or big problem in the early days, of course, was computers were slow. Processes were fast. We needed things to happen faster than we could even with the technology at the hand. So we tried a lot of different things to solve that problem. One of them was to put the multiple processors in the same computer. Like here you had 4 of them, and these chips would all be running at the same time with different tasks. So you split it up, and you're going maybe roughly 4 times as fast as if you only had one chip. Unfortunately, that did not take on. There was never a large company behind it like an IBM or whatever, and it was small, innovative companies that had it, didn't have enough power to make it fly. But as I said before, once mini computers came out, it was a marriage made in heaven. To connect those up to processes and solve and control processes with them, because they were dedicated, and by this time they were a little faster, and we couldn't use procedural language. We still had to use assembly language, but we'll get into that a little later. But still, they proved really successful in controlling a lot of different process controls. Okay, like steam plants, oil refineries, steel mills, pumping plants, so forth. DEC, again, was probably the leading company in the hardware end of it with these mini computers, with their PDP-8. That was their first thing, and there were hundreds of those sold. And you have to realize one thing about process control is, let's say you had a pumping plant with 14 different pumps, okay? So you got 14 different units on the unit level. You got a control room. You got a lot of wire running out there, and a lot of our problems were because of the wire. Well, once we got mini computers, we could put small computers in each unit, okay? And then put a telenet, communicate with a bigger computer in the control room with all the units. Eliminate the wires, and it did a lot of good. Okay, here's a steam plant, and where you melt steam. Computer was really a good requirement there, because there's some variables and controls that have to be just right at a certain time, and it's really time critical. And a computer could do that a lot faster than an operator trying to juggle a bunch of different controls. But the people didn't really understand. The guys running the clean plant, the steel mill that we put a first computer on a steel mill at, they wanted to put the computer right here. And of course, they would have melded the cards, So we had some education to do there. Okay, here's a pictorial of a steam plant, and this will kind of drive home why a computer is really good for process control. You've got a ton of inputs that are all different various values, okay? And those values will create what outputs are happening. And if you have in between the inputs and the outputs a computer that allows you to adjust it to the optimum value it should be, then you really maximize the efficiency of the steam plant. There's a steam plant control room, and even with a computer, you can kind of gather by all these different screens the complexity of running the steam plant. Okay, we finally get into third generation, and that's microcomputers. And we had AMSI from Japan, we had PET, Altair. Those were the three most popular ones. Quite a few others, and you people that have been around a while, you could probably name another half a dozen. At the same time they came out, the chip manufacturers like Intel came out with what they call SDK kits, okay, which would allow you to some limited programming capability to explore these different chips, okay, which they would use in bigger computers, mini computers. AMD had a 6502 kit called KIM-1. Here's the Intel's 8085, and as you can see, in this kit, you could get for a few $100s. Oh man, this is great because like computers, mini computers were $20,000 up to $30,000. So you had nothing you could own at that time. Well, when these came out, the same time, about 72, the internet, boom, came out. The bike shops came out, and life was really good, man. It was, you could start getting your own device and own your own device and so forth. What this one, let's look at this one a little bit. It had a LED output, okay. It had keyboard input. It had the chip itself, and it had two 128 byte single, which gave you a total of 256 bytes. That's all, just bytes of memory. So you're kind of limited in what you can do with 256 bytes, but it was a start. Here's the KIM-1. They added, besides all this, just like the 8085 had, they had added a little bit of logic here to drive cassette recorder. So you could save data or you could load data from the cassette recorder into the computer. And that helped a lot. There was a guy I worked with named Stan, and he bought one of these KIM-1s, and he hooked up, this was before we had really CRTs, but he hooked up a CRT and made two eyes going back and forth with this little program and a paper hand that would wave. Well, we were all pretty young families working for military contractors in those days. And Christmas time, they always had, the company always had a big dinner down on Wilshire or whatever. And the deal was you'd eat the dinner, and then you'd meet other young couples, and everybody get their pictures out and say, hey, these are my kids, this is my daughter, this is my son, so forth. Talk about that. You guessed it. Stan gets his picture out. It's a picture of his KIM-1 waving. Okay, here's Altair. It was a good microcomputer. And this is the company that hired Bill Gates when he left, let's just say left Harvard. What he did is developed a basic interpreter for these people. Here's an AMSI. There was a ton of AMSIs sold. Maybe some of you all still have one or two. PET. They got a little bit more structured in the way they had the cassette in a case and so forth, and all of that. I think that was pretty neat. And again, here's the progress of what happened for the evolution of the internet. And the important one right here is in 1972 when they developed TCP. They came from ARPANET. They developed TCP/IP, and it opened it up to all of us. Okay, so now we had we had an internet, and we could start communicating. Okay, we finally get to the fourth generation computers, And that's, I guess, about 1975. The big mark there was what we call VLSI, very large scale integration. Now, we had already gone from tubes to transistors, okay, but this took us from discrete components like transistors, and so forth, to everything on cards. It pushed everything together. And what that did is really allowed mass production of computers. Well, now you got it doesn't cost as much to make them, so they could sell them for less. And of course, the market was opening up anyway because more and more people wanted computers, and the computers were getting cheaper. So it's kind of a two-way street there. I bought a Trash 80, a TRS 80 from Radio Shack, and it had 2 floppies, a keyboard, CRT, and some memory. $5,000. I know you're laughing because today, you can get like heck, you can get a computer for like $500 or less even. But anyway, that was good, and I put up another $5,000 and bought a Centronics printer, and I was in business. I could make mailing lists and so forth. Same time, Apple's coming out with what they call the Apple II. Okay, gained 2 floppies and CRT and so forth, a keyboard. And I was developing some hardware for a client at the time, and unfortunately, we chose an Apple II. That bus that we were putting our device on was so noisy. It was driving us crazy. Then the whole thing got graced, let's say, by IBM. They came out with the IBM PC, okay? And then 2 floppies again, and the mouse. I think the mouse came out either when they came out with this or shortly after. And a little matrix printer. Apple comes out with a Macintosh. This was their first one. I still got one of those little guys, and I got not this one, but a later model of Mac 2. And you've probably seen this. This is true for today still. These are the components of a computer. You got a CRT. Usually, you got a CD-ROM or DVD, and you got a floppy, and you got a mouse and a keyboard. Okay, we get to the 5th generation. It's laptops and cell phones. Laptop really changed the way we did business in the support business of a computer. Whether you were developing software and going to meetings, you'd take your laptop with you, and during dead times, you'd be still working on your program, okay? Or you were doing support of field operations, and you had all your software tools on a laptop, and you took it with you, and hooked it up to whatever the target machine that you were investigating or installing or integrating. Cell phones are great. I mean, you got a camera, you got audio communication, a telephone. You got you can make pictures with with the camera, and you got email, and you can get on the email, and you have that with you all the time. Okay, peripherals, we used to call all the devices that hooked up to a computer a peripheral device. And in progress, what really changed over all of the different phases of computers, generations of computers, was the peripherals, not the CPU. The CPU operates the same as it did on the first computer. Okay, of course, it's a lot faster now, and it's a lot smaller now. But the peripherals really made the big change, especially in memory. Okay, again, we started off, you remember, on those mainframes, we had relays for your second storage, and we had vacuum tubes for your primary storage. And then along the line, we had delay line and diodes. And then we went to drum, okay? And drum had our primary storage on it. But of course, that's pretty slow because if you missed a revolution, so you had to really figure out how long an instruction takes and how much of the revolution it's going to be, and where, so you could generate the next instruction address to kind of optimize your code. And then we finally got core, replaced drum, and that solved a lot of problems, except it was pretty unstable for a while, and you had to wait for a while. And then RAM replaced that. RAM was the best. And of course, along the line, you had auxiliary storage like for floppies and disk. Okay. Likewise, input and output, whether you had keyboard going in, or you had printer going out, all of these things, they made advances. You had MagTape, you got faster and denser densities, storage densities, things like that. Paper tape, you got high-speed readers and like that. So you went from the 5 CPS to 300, yeah, and fast. And printers, you went from line printers or to single printers to line printers and so forth, and the world got faster. A lot of change in peripheral history. And I got a few slides here that just kind of show what some of the older devices look like. Okay, this here is a computer line memory, which was recirculating. And if you had 2 of these recirculating, they could actually feed an adder, and you could transfer data, the result of that data, back to a third one or back to one of these. So you could compute, and it was pretty early on, and probably didn't last a whole lot long time. Here's good old relay memory, which again were big, bulky, and slow. Diode memory, they were pretty fixed, and as I said before, we had in the air defense, we had a couple of things that had to be done over and over again, and with the input being varied, for different targets. Like we had slant to ground conversion and ground to slant conversion and like that. Now here's these vacuum tubes, and you can just see these big suckers. You can just imagine how much heat those suckers created. Okay, here's the drum memory. Now the drum memory had different tracks, and it had sectors on each of those tracks, so many sectors. And in each sector, you would put an instruction, okay, for your program. And this is the one where you'd say, well, I don't want the next instruction to give me lose a revolution, okay? And a revolution was like 1.4 milliseconds. So you had to figure out the next instruction. If I had an address here, what was the instruction? How long is it going to take? Well, the next one I could put here. So I'd put it there. And here's core memory. And as I said, we used to have to generate like smooth curves or waveforms to tell us how long it was going to be until this core warmed up enough where it would be stable for the day, so we could trust the computer. And then we get RAM. RAM was great. RAM is fast memory. Disk got better and better, smaller and smaller, and larger capacity and larger, and more density and so forth. Floppy disk, okay, you got the big 8-inch. Actually, the 5 1/4 came first, and then the 8-inch, and then the small 2 3/4 inch, which was really not floppy; it was a rigid disk, but they call it floppy. Here's the workhorse I keep talking about, the Teletype, or ASR 33, and in this case, right here, we're feeding tape in using the tape reader to feed that into the computer. In this case, we're taking the computer and then punching out a paper tape. Okay, here's a computer matrix printer. And again, to print this thing, we're sending one character at a time. Bump, 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 bump on a line. So the line's 100 characters long. It's going to, at 5 cycles per second, it's going to take a long time for this printer to print a page. Okay. So they developed a line printer where the whole line was rasterized in the computer. Okay. So everything that was going to print got taken as a line, and we sent the line out to the printer. Whap. One of the things we try to get away from, printers were awfully mechanical. Mechanical has a lot of failures, and we wanted to eliminate some of that mechanics. So we went to devices like the laser printer to eliminate the positioning, on that printer that would say, oh, put the heads here and all that. That did a fine job. And of course, by demand, we needed, hey, why don't we need to be able to store and play with colored pictures, colored images in the computer. So how are we gonna get those back out after we generate them? Well, with a color printer. So we developed an inkjet color printer. Plotters, we had the vector plotter, XY, and then a raster plotter. Okay, faster. And then we were using slides in those days because we didn't have direct output from the computer to a projector. Okay. I mean, it hadn't come yet. So they used a lot of slides. So we needed a device to generate slides. And so we had digital film recorders. Like this and like the Samurai. Okay. About the early 80s, we started really using barcodes and computers in warehouses. All right. And in point of sale. Also, computers and point of sale. So we started using barcodes. Well, we needed a device to read those barcodes. So they developed a barcode scanner, little gun. Okay. Color page scanner. Again, if we're dealing with colors in a computer, there's got to be a way to get them in too, besides get them out. So we had a page scanner. Okay. The cost and the speed and cost history. When we started, because of technology, mainly, computer, and because of the market, how many people are buying computers? Not many. So we had slow speed, like tens of milliseconds, and high cost, tens of thousands of dollars, big time. And of course, as time went on, speed got faster, costs got lower, until we get today. We get speeds, and these are all in instruction time. Okay, well, how long does an instruction take? We've got tens of microseconds for speed, it's pretty fast, and low cost, hundreds of dollars is all. So that kind of shows what happened. And of course, it's perpetual, and they help each other as the cost gets lower to create something like a computer. Then they can sell it for less money, and more people buy it. So it keeps going up. And here's the real reasons again: mass production, because of that integrated type thing I talked about. Device evolution. Like here we had when we were reading off paper tape reader. Now we got high-speed reader. Okay. Okay. In parallel, as the device history went faster and faster and greater, computer software, also the tools that we created for the program that ran on the computers, it evoluted too. Okay, we started off with machine code, and you were reading 10100, and you were writing stuff down on paper, and you were saying, I know that if I have a 1110112, I mean 1, that's a load A. Okay, well, we got to assembly language. Okay, so that gave us pseudocodes. So now when I was coding, I just typed in the LDA. Well, that's a load A, and it's self-documented, and that was a good step. still, it was a every little instruction that we really had to carve out a program to make it work. Well, unfortunately, again, I'll say it, time was the enemy. Computers still weren't fast for a long time, and because of that, and because of memory cost, they were still high. I actually used assembly language in real-time applications for like 15 years. Then they had other things along the way at the same time, like a basic interpreter. If you really weren't time sensitive and you're just doing calculations or something, you can still do faster than people and all that. You could use a basic program to do that, or a compiled Fortran even, or COBOL if you're doing some file management type thing that could take time, or SQL. And then the many compile languages, this is the ones that really got more sophisticated as time went on and as the machinery allowed them to be used, like C. When C came out, that was the first compiled or procedural language that I could use for semi-real time or real time in some cases. And C++ is after that. Java is really popular still today, I think. Pascal, PL1, a lot of different languages. And again, there's another parallel as all that other stuff's happening. The common software packages, and they were very important because who's going to buy small computers? When we got to the mini computer point, the dedicated point, well, we want business people to buy it. We want commercial people to buy these computers. Okay, well, they have to have some common thing that's good to run on a computer. Well, word processing was probably number one. As soon as that came in, and then the first one was like Electric Pencil. I don't have it here, but that was before Scriptset. And that was great. And then we went to Word Perfect, and then Word. And Word has been even greater today. It's got a lot of capability. You can make just about any kind of documentation you want, tables, all kind of stuff out using Word. So Word was one of the first packages, really good. These two other ones, database administration and spreadsheets, were the other two driving element that helped many computers being sold. We could make the boxes, but we needed somebody to buy them. So database administration, we had things like Access, which is still alive today, Oracle, SQL, things like that. And we had spreadsheets. VistaCal out of Boston, that was the first spreadsheet. Today we have Excel. We had Lotus 123 in there after VistaCalc. And I remember before 1980s, as far as warehouse was concerned, we were running the warehouse on a spreadsheet, which you could do. You could still better than manual. That was the technology of the era of the time. Okay, of course, along the way, we developed presentation graphics like the PowerPoint I'm using today. Okay, this is presentation, image one, things like that. Project planning became really good because as projects got more sophisticated and you had more programmers working on the project, and you had to really tie in these dates of how long is it going to take and what do I need working before my part works, and vice versa. That really, the project and like that really, really helped. And of course, the big companies had the operating systems like DOS, which is still used today by the VA, by the way. I think it's being replaced, but who knows. Unix, OS/2, Windows, Linux, Red Hat, and all that series of stuff. And of course, they were good. I should have put Mac down here too, but I am a PC guy. Sorry. Email. Okay, email became, when the internet hit, that created the requirement for email, and email paid off big time. I thought with email, and when the fax came out, I thought, hey, that's going to change communication big time, and it did. But there's one company particularly that American Express, that delivers. Okay, I thought they were history at that time, but they weren't. There are still classified things that are needed and so forth. And then search engines, as you know, the internet is great. It's got all kinds of information you can get. Not qualified, but still information. And how do you find that information? Well, you do it with search algorithms, okay? And these have been produced by Google, Facebook, and companies like that. And that's what gets it, because I want to get information off the internet. I'm using one of these search engines to find it. Okay. Scared myself. I thought it stopped. Huh, it's funny. Anyway, here's machine code. As you can see, it's just ones and zeros. Okay, what I thought is I would give an example of the difference between assembly language and a procedure language. Say you had a problem where you were collecting, do the accounting for collecting money, or for an item or whatever. So this is what it might look like in assembly language. You're going to load LDA, load A with the new, get the amount just paid, and then add to that A register what they'd already paid. So now you've got their current value, and you store that back into paid. Then you compare A to full. Are they done? Have they paid the full amount? And if not, you jump to next, get the next guy. If so, then you go to done. Okay. Now you go to procedure language. It would look like this. Very easy. Paid equals paid plus new. If paid equal full, then go to done. Else, go to next. Pretty easy. Well, thank you for paying attention or whatever. We'll see you around.